All right, we got ourselves a Hess's Law problem here. And I love Hess's Law problems because they're really just like puzzles. There's not a whole lot going on as far as concepts and chemistry is concerned. All we need to do is we need to take these equations that we're given and we need to manipulate them so that when we add them all up, they'll form the reaction that we're looking for. And then when we add up all those manipulated enthalpies, then we'll get the enthalpy of the reaction we're trying to calculate the enthalpy for. So the way to do it is to just approach it from the reaction that you're trying to form and just do it from left to right, one reactant to one product at a time. And so let's take a look. We're going to start with P4. I'm going to look for a reaction that has P4 in it. Look, there it is. It's on the correct side and it's in the correct stoichiometric proportion. In other words, I need one. And so I'm just going to rewrite this whole reaction exactly like it's written. And then I'm going to write down the enthalpy exactly like it's shown. So that's negative 1774 kilojoules. Okay, let's go to the next reactant. It's chlorine. But look, I've got chlorine already in the reaction that I just used. It's not in the correct stoichiometric proportion, so we're going to have to sort it out later. So let's just go ahead on to the next thing, which is PCl3. Now, I see I need 4 PCl3, and there's PCl3 in the other reaction. And so what am I going to have to do? It's on the wrong side of the reaction, so I need to reverse the reaction. I need to flip it. And so after I flip it, though, it's also not in the correct stoichiometric proportion. I need to multiply it by 4. So let's go ahead and then rewrite that second reaction by flipping it and multiplying it by 4. So we get 4 PCl5 goes to 4 PCl3 plus 4 Cl2 gas. And then what I need to do with the delta H is I multiply it by 4. So since I also flipped it, I need to make the sign opposite. So if we flip the reaction, we need to reverse the sign of the delta H. Okay, so let's see what's going on. I have used all of the reactions that I was given. And so when I use all the reactions that I'm given, I'm pretty sure that I'm done. And so I need to make sure that that's the case. So let's take a look. We needed to deal with the chlorine, and there's 4 chlorine on the product side of that reaction, 10 there. And so 4 minus 10 is 6. And that gets me the 6 that I was looking for. So that looks great. Also, the 4 PCl5, which isn't in the reaction that I'm looking for, will cancel. So that's also great. So it looks like I've got the 4 P4 that I need, the P4 solid that I needed, one of them. I got the 6 Cl2 that I needed, and that's great. And I also got the 4 PCl3 that I needed. And so I'm ready to go. So all I'm going to do is take this and add them all up, and I get negative 1,278.8 kilojoules. So now I know that the enthalpy of the reaction is negative 1,278.8 kilojoules. Okay, that's it.